Precalc Honors, quarter 3, final review. Number 1, we're going to use the tech. We're going to hit the area button. We're going to turn it on, but first we're going to make sure we're in degree mode. This one here, we're going to use radians, but we're going to use the chart. So we'll keep it in degree mode for the whole test. We're going to hit the area button. And we're going to type in 5 alpha red X. It already has the dx down arrow from 0, up arrow to 2. Hit equals, and it kicks out our answer pretty quickly. It's 10. For number 2, it's the same concept. So again, we're going to use the area button. So I'm going to hit that area button. We're going to type in 3 alpha red X. But this time we're going to hit the X squared button to square it. We're going to down arrow. We're going to start at 0. We're going to up arrow, end at 2. And it finds the area under the curve. And that's going to be 8. So what we want to do is we want to take the antiderivative of secant, or secant squared. So on my wall, I have this note. So notice, it's secant. So I'm going to put my finger over secant, and it points to the word tangent. So the antiderivative of secant, or secant squared, is tangent. So that's going to give us tan x evaluated from pi over 4 to 3 pi over 4. Now using our chart, we're going to find out what tangent of 3 pi over 4 is. So on our chart, tangent of 3 pi over 4 is -1. So this value is going to equal -1. Then we're going to find tangent of pi over 4 on our chart. So on our chart, tangent pi over 4 is 1. So by the fundamental theorem of calculus, we have to do -1, this value, minus 1, this value. And all that work gives us -2. For number 4, this is an area problem, but it's not a calculus area problem. We're just going to use the calculator. So the area of a rectangle is base times height. So we're just going to do the square root of 24, right arrow times the square root of 6. And that just equals 12. I would not use AI for number 5. It doesn't work out the way you want it to. It doesn't read it for some reason. So for number 5, what we're going to do is we're going to split it up or add to it. I like to add to it. So now the height of this is going to be 2 plus that 3. So that's 5. So the area of the big rectangle would be 60. And then I have to subtract this area here of 9. So the total area for number 5 would just be 51. Some people like to chop it vertically. So that would give me 12 minus 3. This top side would now be 9. This little rectangle here would be 2 times 3, that's 6. And then 9 times 5 is going to give us 45. And 45 plus 6 gives us 51 again. Other people like to slice it horizontally. So that would be 2 times 12 is 24. And then 3 times 9 is 27. And when you add those up, you get 51 as well. For number 6, we're going to find the area of the shaded region, or the area of the sector. That formula is 1/2 r squared theta. Since the radius is square root 6, so 1/2 root 6 times root 6 is just 6. And then we need to find 60 degrees in radians. So we could either use our unit circle or our chart. On our unit circle, it's 60 degrees. The radian measure is pi over 3. On the chart, you can just scroll along the top edge. So it's 60 degrees, it's pi over 3. So that's going to be 1/2 times 6 times pi over 3. If you're not great with your arithmetic, you can use the calculator, but this is going to equal 6 pi over 6, or just pi. To find the hypotenuse, So what we'll do is the square root of 24 squared plus 7 squared. Again, it's always nice to do it in the calculator. So when we type that in, we get 25. Now we'll label it up. So the hypotenuse is 25. The opposite side from theta is 7. And 24 will be our adjacent side. Some old horse caught another horse, taking oats away. Opposite over hypotenuse, so 7 over 25. Adjacent over hypotenuse, that would be 24 over 25. Opposite over adjacent, 7 over 24. The reciprocal identities, we just flip them, so that would be 25 over 7, 25 over 24, 24 over 7. To find theta, we're going to have to do the shift sign. So we're going to do arc sine of 7 divided by 25. And remember, we have to be in degree mode. So shift mode 3 will put us in degree mode. Shift sign of 7 divided by 25. We'll round to the nearest degree, which is 16 degrees. To find gamma, we're going to do 90 minus that angle, so 90 minus 16 to find gamma. 74 degrees. The area is 1/2 the base, which is 24, times the height, which is 7. So 0.5 times 24 times 7 gives us 84. The perimeter, we're just going to add them up. So the perimeter would be 25 plus 24 plus 7. (56) is our perimeter. So number 8 is graph y equals 1 cosecant pi over 4. So our amplitude is going to equal 1. Our period is going to equal 2 pi divided by 4. So our amplitude's pretty easy. That's going to be 1. And then let's use the tech if we want to get an accurate thing for the period. So 2 pi, remember the pi button's way down here. You have to hit shift and then pi to get the pi to appear. Down arrow, and then shift pi again, and then divide by 4. And this will cover the order of operations. So our period for this trig identity is going to be 8. So we go out 1, 2, 3, 4, and we're going to put an 8 there. Half of 8 is 4. Half of 4 is 2. Multiply 2 by 3, and that would give us 6. 2, 4, 6, 8. Cosecant is 1 over sine. Sine starts at 0, 0. And then because our amplitude is 1, I'm going to go up 1. I'm going to go down 1. And these are going to be our upper and lower bounds. It starts at 0, 0, and then goes arriba, el centro, abajo, el centro. It's going to oscillate. Now, while I'm sketching this, I have to realize I'm not supposed to be graphing sine. I'm supposed to be graphing cosecant. So wherever sine is 0, the cosecant is going to be 1 divided by 0, which is going to generate a vertical asymptote. When we're done, we should have a plethora of vertical asymptotes. For 9, we're asked to graph cotangent. So we have that in our journal, and our quarterfinal is open notes. So y equals a cotangent bx. When it's just cotangent is 1, cotangent 1x, we could use the chart, but we already have our graph here. So the period is from 0 to pi. That's where the asymptotes are going to be. So at 0 and at pi, I'm going to put my vertical asymptotes. And you can see that if you look at the table of values. Cotangent of 0, it's undefined. And then at cotangent of pi, it's also undefined. Half of pi is pi over 2. Half of pi over 2 is pi over 4. And then you multiply that by 3, and that would give us 3 pi over 4. So cotangent of pi over 4, cotangent of pi over 4 is 1. Cotangent of pi over 2, cotangent of pi over 2 is 0. And then cotangent of 3 pi over 4 is going to be negative 1. And our graph will come along there, go through, and then skim down along that asymptote. For number 10, we're going to use the side angle side. You could use the triangle solver, but this one's pretty quick in the calculator. It's just going to be 1/2 or 0.5 times 6 times 8 times sine 30, but we don't have to put a times there when we type this into our calculator. And again, we should keep our calculator in degree mode. So 0.5 times 6 times 8 times sine 30. 0.5 times 6 times 8 sine 30. It's going to give us 12. 12. For number 11, we're going to use the formula. You could also use triangle solver. Be careful, you have to label it up correctly though with the lowercase letters. So our area, we need to find a perimeter or a half perimeter. So the perimeter is going to be 12 plus 11 plus 7, and that'll add up to 30. And S is a half perimeter, so we cut 30 in half, and that equals 15. In our radical, we're going to put 15 here for S. And then we have to do 15 times 15 minus 12. Well, 15 minus 12 is 3, times 15 minus 11. 15 minus 11 is 4, times 15 minus 7. So that would be 8. Square root of 15 times 3 times 4 times 8. (12√10), but we don't want it in radical form. We want it to the nearest whole number. So all we do is hit the SD button, and 37.94 will simplify to 38. For number 12, we can also use the triangle solver. I'm going to use the formula for law of sines. So the first move, all I need to do to find angle A is 180 minus 110 minus 40. So that's going to give us a 30-degree angle for angle A. Inside A, we're going to have to use the law of sines. So that's going to give me sine of angle A and side A is equal to sine of angle C and side C. Our calculator key in, when we type it in the calculator, we have to use parentheses for all these, and be careful. So we're going to cross multiply sine 30 times 20 divided by sine 110. So sine 30 times 20 divided by sine of 110. Nearest whole number would be 11. Find side B, our remaining side. Find side B. Again, we're going to use law of sines. So we're going to keep this relationship going here. So I'm going to copy that down. Sine of 110 over 20 is equal to, but now I'm going to set up a relationship with side B and angle B. So angle B is 40 over lowercase b. So sine 40 times 20 divided by sine of 110. Now, if you want to be a little tricky, all you have to do is keep your old answer in there and back arrow into the sine 30 and just change that to sine 40. You could retype it in if you want, but you don't have to. So that's going to be 13.68. If we round that to the nearest whole number, that would be 14. So if I have 10.6 there and 13.6 over here, if you want to round it or leave it at the 13.6, we're going to find the area. We're going to find the area now using these numbers. So I have 30 degrees here. I have 13.68. And I have 20. So we're going to go back to our formula up here where it says find the area using the half angle formula, the side angle side formula. So that calculator key in is going to be 1/2 AB. So I'm going to do times 20 times 13.68 sine of 30. And then we'll round that answer to the nearest whole number. 0.5 times 20 times 13.68 sine 30. And then we'll hit the SD button to get that, and that's going to be 68.4. We round that to the nearest whole number, and that would be 68. Solving trig equations, we're going to add 1 to both sides. It's going to give us 2 sine x equals 1. Then we'll divide both sides by 2. That'll give us sine x equals 1/2. So where on the unit circle or a chart does sine x equal 1/2? So sine x equals 1/2 at 30 degrees. Sine x equals 1/2 again at 150 degrees. And there's only 2 slots there, so I'm comfortable to believe that we're done with that at 30 and 150. For number 4, notice number 4 has 4 slots, so there should be 4 answers for number 4. Solving the trig equation, we're going to add 3 to both sides. So it's going to give us 4 sine squared x equals 3. We're going to divide both sides by 4. So that'll give us sine squared x equals 3 over 4. The opposite of squaring a number is square rooting. Remember, there's a 2 hidden in there. That's why we square root it. So we add a square root, we add a plus minus. So this is going to give us, where does sine x equal plus or minus the square root of 3 over 2? So we're going to go to the chart and find out where sine equals plus or minus square root of 3 over 2. And there should be 4 places. So sine equals square root of 3 over 2 positive at 60 degrees. Square root of 3 over 2 positive at 120. Square root of 3 over 2, going off the screen, hold on, negative at 240. And then again at 300. Number 15, we're going to solve this trig equation. So we're going to add 3 to both sides. That'll give us 9 cotangent squared x equals 3. We divide both sides by 9. That'll give us cotangent squared x equals 3 over 9. We're going to square root everything and add a plus or minus. So where does cotangent x equal plus or minus root 3 over 3? Where does cotangent equal plus or minus root 3 over 3? So cotangent equals root 3 over 3 at 60 degrees. Negative root 3 over 3 at 120 degrees. Positive root 3 over 3 at 240 degrees. Negative root 3 over 3 at 300 degrees. mx plus b. Slope is 17. Number 17, mx plus b. Slope is 2/3. Number 18, x over 5 can be rewritten as 1/5 x. So now it's in mx plus b format. So for number 18, that slope is going to be 1/8. For number 19, that's a horizontal line through y equals 7. And its slope is the hoi part of hoi. So its slope is going to be 0 for 19. It's a vertical line, a vux. So a vertical line through x over x equals 2. And that slope is u, or undefined. Number 21, this is in the format of point slope form. So y minus y sub 1 equals m times the quantity x minus x sub 1. So the slope is right there, it's 2. Number 22. Slope is opposite of a over b. So a is 5, b is 3. So the slope is going to be negative 5 over 3. Opposite of a over b. So negative 2 over negative 3. That'll simplify to 2/3. Positive. And the slope of 5x squared minus 3x at the ordered pair 214. So to find the slope at a point on a curve, we want to take the derivative. So the derivative of 5x squared minus 3x is 10x minus 3, evaluated at x equals 2. So 10 times 2 would be 20, minus 3, the slope would equal 17. There is a way to do that on the Casio. I'll shift area, and it brings up this DDX menu. And we want to type in 5x squared minus 3x. So 5 alpha red x squared minus 3 alpha red x, right arrow, and the x value that we're finding the slope at is 2. We hit equals, and it should give us the slope. There it is, 17. When they get more complicated, you're going to rely on the tech, but the simple one like this, you can do by hand. The slope of sine x at pi over 3. So the derivative of sine x is cosine x. So I want to find cosine of pi over 3. On the chart, cosine of pi over 3. Cosine pi over 3 is 1/2. Cosine pi over 3 is 1/2. So that slope is going to equal 1/2. Number 26, I want the equation of the line in point slope form. That's y minus y sub 1 equals m times x minus x sub 1. So if I have y minus y sub 1 equals m times x minus x sub 1, I can fill in this template pretty quickly if I leave some blanks. So y minus something equals the slope times x minus something else. The y value is 3, so it's going to be y minus 3. The slope is 2, and the something else is 1. So 3, 2, 1. And I had that one templated out for you. For number 27, y minus y sub 1 equals m times x minus x sub 1. So y minus a blank equals a blank times x minus another blank. So the 1/2 slides down. The root 3 over 2 is the slope, and the pi over 6 is the x value. So we're going to copy that down over here on our answer slot. Y minus 1/2 equals root 3 over 2 times x minus pi over 6, close parentheses. 28, we want the equation of the tangent line to the curve at the given point. So the equation is 5x squared minus 3x, but the equation of the tangent line has to be a line. So we need to find a slope. So y prime equals 10x minus 3. We plug in the 2. 10 times 2 minus 3 is going to give us 17. Now we're going to take that ordered pair and that slope and use the point slope form. So y minus 14 is equal to 17 times x minus 2. For number 29, this one's a little bit more involved. Derivative of sine at pi over 4. So the derivative of sine is cosine, but we're going to plug in pi over 4. The slope at cosine of pi over 4, cosine pi over 4 is root 2 over 2. So again, we're going to use the point slope form. So y minus y sub 1, which is root 2 over 2, equals m, which is root 2 over 2, times x minus x sub 1, which is pi over 4. The derivative of tangent, I think I'm going to need a note for that one. The derivative of tangent is secant secant. So that's going to be secant squared x at pi over 4. So I need to know what secant of pi over 4 is and then square that. So let's go to the chart and figure out what secant of pi over 4 is. Secant of pi over 4 is root 2. So that's going to give us root 2 squared. So the slope is going to equal 2. So I have my point and my slope. So my equation is going to be y minus 1 equals my slope times x minus pi over 4. Tangent's on my calculator. I'm going to put this thing in radians and see if it kicks out a 2. Shift mode 4 is radian mode. I'm going to hit my shift area button to get the ddx. Tan alpha red x, close parenthesis, at pi over 4. At pi over 4 is where they want us to find it. Shift pi, down arrow 4. Let's see if it can handle it. 2. It did it a heck of a lot quicker than I did using the chart. E equals 2.718. I equals the square root of -1. Pi equals 3.14. Phi is the golden ratio. That's 1.618.